Right, grade 12. In this lesson, I just want to briefly revise the concept of average gradient and then derive a formula for average gradients and hence for the gradient of a curve at a point. Now, don't panic with this. This is not really for exam purposes, but just for interest. I've got a curve F, and if you remember, if you choose that as point A and that as point B, what do you remember? The gradient of line AB is the average gradient of the curve F between A and B. And as we chose specific points on the curve, if you remember that, if we chose points, as you worked out the gradients of the lines joining these different points, you found that the average gradient of the curve between those two points changed. And eventually what happened? The gradients approached the tangent line to the curve at that point A. So I'm just going to draw a little tangent in here. There it is. It passes through point A, and it looks like that. Okay. What we also have is, if you notice here, we could have had, if you take between A and B, you've got the black line. Then if you carry on and you go to that point there, you had a different gradient, and if you eventually went to, say, this point here, you had a very different gradient there. Okay, so you had the black line, the pink line, the blue line, and eventually the purple line. And these gradients changed, and eventually they approached the gradients of the purple tangent line at that point A over there. Okay, now what I want to do is I want to create a formula for average gradients. Now, have a look at this. I'm going to call point A X. Okay, I'm going to now add on a value to X, a positive value, and I'm going to call that H. And eventually when I get here, I've got X plus H. Now don't panic with this, it's not for exams, it's just for interest. And just to give you some idea of how this formula is going to work. Well, if that is X, the corresponding Y value is the F of X here. Okay, and the corresponding Y value here would be the F of X plus H. Alright, for point B. So A would be the point X and Fx, and B would be the point X plus H, F of X plus H. Okay, cool. That's a point for X and a Y value there for A. For B, you've got X plus H as its X value and Fx plus H as its Y. Now, what is the gradient of line AB? If we look at the gradients, the M value of AB, the gradient would be simply the Y of B minus the Y of A divided by the X of B minus the X of A. Now, watch this. If we work out that, well, the Y of B is F of X plus H, and the Y of A is Fx. So let's work that out. So that gives us the F of X plus H, subtract the F of X. Those are the Y values. Then we divide this by the X of B, which, if you think about it, is X plus H. There it is, X plus H. And what is the X of A? Well, that is X. The X of A is, of course, X over there. Okay, and then you'll notice that the X's cancel. So we're left with a little formula called Fx plus H minus Fx, all divided by H. Okay, now this is the gradient of line AB, or this is also referred to as the average gradient of F between points A and B. Okay, now if you remember from the previous lesson, we started working out the gradients of the other line, and we noticed that they all approached the gradient of the purple line. And what happens here is, if you look at this carefully, if you take the distance, look at this here, the distance between the X values, you notice that this distance is actually approaching naught. The H is approaching naught. As the points get closer, that distance is getting closer and closer to naught. We started like that. Now look at this. It's getting smaller. And here it's getting smaller. So eventually that distance H is approaching naught as the points approach A. Okay, quite technical, but don't worry about this. It's just to give you some idea of it. And what we can say is that if you work out the limit as the distances between the X values approach naught, this gradient, the gradients of line AB, which is this formula here, is going to approach the gradients of the tangent line. Okay, the gradients of the tangent line which passes through the curve F at point A. So we have a new limit. Now don't panic with this thing. They're not going to ask you to derive this as I've done here. It's just giving you some idea of what's going on. This formula here is the average gradient between A and B. It moves as it changes, as the distance between the distances between the 2 points, A and B, as they get closer, these points get closer and closer to A, the gradient is changing, and it's almost like a limit. The limit as the h's go to naught, the distances between those 2 points go to naught. We've got a little formula called this, and this formula, which they refer to, now watch this, as f prime x, it's got a new notation. That symbol means the gradient of the f is equal to the limit as h approaches naught of fx plus h minus fx. By the way, they give you this formula on a formula sheet in the exam, and this is referred to as the gradient of the curve, okay, the gradient of that curvy curve there, okay, at the point A. Remember, we're no longer talking about the average gradient between 2 points. We're talking about the gradient of the tangent at point A, which is also the gradient of the curve. That is the most important principle that you really need to gain from this. So this formula is referred to the gradient of f, or the gradients of the tangent. Let's call that tangent t, the gradients of the tangent at point A. So what it's saying very simply is, if you've got a curve, it could be a parabola or anything you like, that's the curve f, and you pick a point, whatever that is, let's call that point A, and you draw a little tangent there, okay, that's called tangent. The gradient of the tangent is equal to the gradient of the curve at that point A, okay, and the way we determine the gradient of the tangent, which is the gradient of the curve, is to work out this limit, this formula. Limit as h approaches naught, fx plus h minus fx over h. Remember, it started at a point between A and B like this. It started between A and B, and as the points on the line approached the tangent, you saw that the gradients changed, and the gradient of the tangent becomes the approach point of all these little lines joining the points. Okay, so the gradient of the curve itself at that point A is the gradient of the tangent. That's all you need to remember now. Remember, average gradient is about between 2 points. Okay, and what is very, very important about this whole thing, if you look at a curve, have a look here, there's a curve, call it f, and you've got a point A there. Okay, and that's whatever x value that is there. Let's suppose that the x is 3, for example. Well, if you look at this carefully here, the y value is the f of 3. Okay, that's the y value, and we're going to do a lot of this. But if you talk of f prime 3, that is the gradient of the tangent at that point A, which is the gradient of the curve. So all you have to remember now, and this is the important thing, is that the gradient of the tangent, the gradient of the tangent is the gradient of the curve itself at x equals that point 3. Alright, and we call it f prime 3, and it's worked out by working out that new limit, and we're going to do a lot of examples that relate to that. Okay, so please be aware of that the gradient of the tangent is the gradient of the curve at that point A. Alright, and the f of the x is the y value, but f prime 3 with a little line there is the gradient of the tangent to the curve at that point A, which is the gradient of the curve itself. So don't get too bogged down now with that formula. It's quite a complicated principle. The most important thing is to know that limit as h goes to naught, this formula here, is this one that we're dealing with here is the gradient of the curve and the gradient of the tangent at x equals a. So if we then look at an example, say for example I took a parabola here. Let me just make up one quickly here. I've got a little parabola, okay, like this, and we can call this graph fx is equal to x squared. Okay, now let me pick an x value. Let's say I choose x is equal to 3. What would be the y value at 3? Well, that's pretty straightforward. You just go f of 3 and you plug it into the equation, which gives you 9. In other words, that's the point x is 3, y is 9. That is the point 3, 9. The y value is 9. It's the f of 3. It corresponds to x is 3. But if I said to you, how do you get the gradient of the tangent at that point A there, let's call it A, the gradient of the tangent, well, it's very much the gradient of the curve. So they could say, what is the gradient of the curve at 3, which is the gradient of the tangent at 3? Now we need to use that formula, that limit formula. Now let me show you how we do it. What we do is we work out the limit. In other words, we work out as f prime x is the limit as h approaches naught of fx plus h. Now watch this, fx plus h minus fx divided by h. We've got to work out this limit relating to this curve fx. Now how it works, people, is going to be really what forms part of the next lesson. But what we do is we start off with fx. Now I want you to watch this carefully. We know that fx is x squared. We know that we've been given fx as x squared. Now the trick with this is to now add an h to the x's. So if I go and I add an h to that x over here, I must add an h to the x on the right. So fx is x squared, that's given. F of x plus h is x plus h all squared. Okay, now once you've got this, you could easily work that out. It's x squared plus 2xh plus h squared if you multiply that out. Okay, now all you've got to do, you've now got fx plus h, is you go into this limit. So you say f prime x is the limit as h approaches naught. We've already got fx plus h, which is x squared plus 2xh plus h squared, which is that. We subtract the fx, which is now x squared, and we divide by h. Now all we've got to do is limits. Now watch this. Equals the limit as h approaches naught, the x squareds cancel, and you're left with 2xh plus h squared over h. Okay, that is f prime x, the gradient of the tangent or the gradient of the curve itself. Then now look at this. F prime x is equal to the limit as h approaches naught. Now as we did limits, you're going to take out that h on top there, and you've got 2x plus h divided by h. That's what we normally did with limits, and we cancel those as we did before, and we've got f prime x is equal to the limit as h approaches naught, and we've got 2x plus h here. Now all you have to do is plug h going to naught approaching there, so f prime x is equal to 2x plus the naught there. And then all we have to do is say, well, what is the gradient at 3? F prime 3 is 2 times 3, which is equal to 6. And that is, this here is the gradient of the tangent, which in turn is the gradient of the parabola itself at x equals 3. Now I'm going to do a lot more examples. That's just to give you a rough idea of what we did.